Doctor, I need your help. I'm only 22 and my knees are already starting to crack whenever I stand up. I feel like my grandma. My roommate says that I need metformin. Do you know what it is? Is it the drug that makes you immortal?
So metformin has actually been around for decades treating diabetes, but lately it's getting more buzz for its possible anti-aging effects.
So, is it all just hype? Or is there actual science behind it?
I'm so glad you asked. I've actually prepared a video about this very topic after the 15th patient this week asked me if metformin was going to help them live long enough to pay off their student loans. Let me show it to you.
Of course, I need to know if my friend is lying.
Of course.
The Truth in Aging Interventions, where we separate scientific fact from wishful thinking. Today we are exploring metformin. Metformin is one of the most widely prescribed drugs in the world for type 2 diabetes, but recently it's been gaining attention for something completely different: its potential to slow aging. But is metformin truly a miracle pill we've been waiting for, or just another health trend that'll disappear quickly? Let's dive into what the research actually shows. To understand how metformin works, we need to talk about why we age. As we get older, our cells become less efficient at producing energy and removing waste. This leads to what scientists call oxidative stress, damage that builds up in our cells over time. Metformin helps by activating the AMPK pathway, which is like your body's energy management system. When activated, AMPK improves how your cells function in several important ways. It boosts energy production, reduces inflammation, strengthens your natural defenses against damage, and helps clear out cellular waste.
Discussions about the potential anti-aging effects of metformin began in 2010 when researcher Brian Onken and Monica Driscoll studied the effects of metformin on C. elegans, a roundworm commonly studied by biologists. They found that moderate doses of metformin increased median lifespan by a few days, though maximum lifespan remained identical. The authors found that metformin induced a dietary restrictive state and did not affect the insulin signaling pathway, as they had expected, given that metformin is commonly used to treat type 2 diabetes. The scientists also observed that roundworms treated with metformin experienced decreased fertility, suggesting that there is a trade off between increased median lifespan and reproductive health. These promising results led to further studies examining the effect of metformin on animal species, much more closely related to humans, to see if these side effects could be mitigated or eliminated.
A more recent study looked at male cynomolgus monkeys. These monkeys are our distant cousins who share about 93% of our DNA. In the 40 months that they studied these monkeys, scientists found that long term metformin use was not only safe, but actually slowed down biological aging markers. The drug fought inflammation and kickstarted DNA repair pathways that normally decline with age. As we age, our brains begin to shrink. This study found that metformin slows these actions in adult monkeys that took the drug versus those that didn't. Here in this image, the red indicates that the brains of monkeys on metformin were actually thicker after long term treatment than those who weren't on the treatment. Most impressively, metformin generally turned back the protein aging clock in these monkeys by an average of 6.41 years in all major organ systems. Relatively few studies have been performed studying the anti aging properties of metformin on humans. Recently, a group of scientists led by Dr. Jamaji Nwanaji and Werem studied the anti aging and weight loss effects of metformin on overweight breast cancer survivors in a 6-month study. The scientists found no statistically significant evidence that metformin slowed any significant aging biomarkers compared to the placebo controls. These preliminary results suggest that the metformin's anti aging effects may not translate to humans. However, this study examined an incredibly narrow sample that is unrepresentative of most human populations. The median age of the participants was 63 years old, so it is entirely possible that metformin does not have the same effects on older adults who already show signs of aging. Short term metformin use may not be enough.
So, what's the verdict? Based on our dive into the scientific literature, metformin shows promising anti-aging effects in multiple species. It has been shown to increase mean lifespan, potentially at the cost of the ability to reproduce. And at the moment, results in humans are limited and inconclusive. Metformin might one day be part of the anti-aging toolkit, but for now, it's not a miracle drug. We need more long-term human studies, especially in human adults.